So as we prepare for quiz 1, preparation for what? For quiz 1. You see? Quiz 1 is almost whatever you see here, you can see it there, you can see it here. So as we prepare for quiz 1, we continue doing some work. So for now, we're going to look at sets simplification. So examples. One, simplify x complement union y minus x complement. So this is going to be, remember how the complement from outside, when it comes inside, it changes the operation. If you have union, it makes it intersection. And then so here we have double complements, intersection, y. So to change the minus becomes intersection x complement. Then we have a complement coming from outside the bracket. And we move, so we'll have x intersection y complement. Again, we're now moving the complement from outside again here. So it will change intersection to union and then double complements, that will just be x. Then here we use absorption law. You get it? Absorption law. That says that if I have this set outside and inside with different operations, everything is absorbed. So we get x as our answer. I hope you pick that. The absorption law says, so if this set is outside and it's also inside with two different operations, with another set inside, so you get that set that appears twice. It absorbs everything.
Sir, what if the operation was the same?
It was the same,
Mm.
then it would be a different situation. So if we had, for example, if we had x intersection y complement intersection x, we were going to get y complement intersection.
No. Okay.
So there is no absorption there. Look at this one. We have y union x intersection y. What's the answer?
It's
What's the answer?
y.
It's y.
It's y.
Yes. Using the same law, is it? Even if you don't mention the law, it's still the same thing. Let's look at C. C is x complement union Y intersection X complement. So we dispute the complement again. We have X intersection Y intersection X complement, which becomes X intersection Y complement union X complement. So that's how you get that. So it will be X intersection Y complement union X intersection X complement. So you see, this is empty. So we'll get X intersection Y complement union empty. So this just gives us X intersection Y complement. Okay, simple. Let's go to example 2. Example 2. We're saying if A is a subset of B, simplify. A intersection B. So if A is a subset of B, if I was to shade, this is A, this is B, sitting in the universe. So if you have to shade A intersection B, we'll shade that part, meaning that A intersection B is A, if A is a subset of B. B, A complement union B. A complement, so if this is A and this is B, A complement is outside A. Union B. In fact, A complement goes all the way outside. If there's a universal there. Union B. So we're shading here. Union B means go back and shade the whole B. I said the whole B. The whole B. Then union means everything. So whatever it has been shaded, which is, let's call the universal E. Let me call the universal E. So the answer here is going to be E, the universal set. Then we also have A intersection B complement. So we have A, this is A, that is B. B complement is outside. Does it intersect with A? No, so we get empty. So I want you to be filling up the gaps. So I'll leave you with D, A complement union, B complement. I'll also give you A complement intersection, B complement. Yeah, so you solve this. And that. Okay. Example 3, we want to talk about real numbers. That is rational versus irrational. Rational versus irrational. So we move. Example 1 under this title, express in the form A over B. One 2.14 bar. So here we have a well-defined procedure. So you say, let X be this guy. And then I check if all the numbers after the decimal point are under the bar. If so, I multiply by how many they are. So there are 2, I'll multiply by 100. Then I'll have 100x is equal to 1214.14 bar. That means 100x minus x is equal to 1214.14 bar minus 12.14 bar. So we get 99x is equal to 1202. When we subtract, then divide by 99, divide by 99. Okay. So it means that x is equal to that guy over 99. B negative 4.523 bar. Again, we let x be negative 4.523 bar. And then multiply by 10 first to remove that 5 from that position. So we'll have 10x is equal to minus 45.23. Multiplied by 100. To move those one step to the left, so now it's 1000 x is equal to minus 4523.23 bar. Then we subtract 1000 minus 10. That's 990. And then here we get 23.23 bar minus 45.23 bar. So this they go. Then here 1, 1. So we get 8. And then 4, 1. We get 7. And then 4, 4. So because the down part has become plus, so the minus remains in the solution. So we can divide now. So x is equal to minus 4478 over 990. Of course, you can simplify there.
Sir, can you kindly repeat on how you got the 10x?
So the 10x, we multiplied this whole thing by 10. Why? So that we move this 5. This 5 is not under the bar, and yet it's a decimal place. So we move it one step to the other side, where we should have numbers that are not under the bar. That's why we have to multiply by 10. When we do that, then you forget about this forever. You now concentrate on this one, which has numbers of this type alone and those under the bar on the other side. So that when I come back now, I multiply by how many zeros there? So 2 zeros, meaning by 100. So whatever I do on the right, I also do on the left. Like that.
All right, thank you.
Okay. Next. Okay, so since this part we've talked about, okay, no, there's another one that is nice. There's another one that's nice. My examples, let's call it example C, this one. 9.42 bar minus 0.25. So you first attend to the first one. Let x be 9.42 bar multiplied by 100. So we'll have 100x is equal to 942.42. Then 100 minus x, we get 99x. And then 942 minus 9, we get 933. Yeah. Yes. So those the decimals, they will cancel each other there. So now divide by 99, divide by 99. So x is equal to 933 over 99. Like that. Okay. I think this, then we go to the other one, 0.25. Okay, this one is easy. I just put a 1 where there's a decimal and 0 the other side, so that I have 25 over 100 as a fraction. I can simplify 5 up there. In fact, 25, 1 in 200, that's 4. So what I have now is 9.42 bar minus 0.25 is equal to 933 over 99 minus 1 over 4. So you can work out the fractions, because now they are fractions. So even if I find that they are decimals or with bars, the thing is I should first attend to the bars separately. Attend to this bar and the other bar, and then put them together. Work it out. Your exercise, you work out this. You work out this. And then you work out this. Any questions?
So I have a question. So let's say there are two numbers before the numbers with a bar. You're supposed to multiply them by 100?
Yes.
No.
Multiply by 100, and then the remaining number will force you to multiply by 10.
All right.
The next, complex numbers now. So A, 1 plus 2i squared. You multiply 1 plus 2i multiplied by 1 plus 2i. That is 1 times 1, 1. 1 times 2i, 2i. 2i times 1 plus 2 times 2, 4. I times I I squared. So we get 1 plus 4i, 2i plus 2i, and then I squared is -1. So we have -1 times 4, that's -4. That means we get -3 plus 4i. So that means we get -3 plus 4i. Not so complicated there. Then another one, 1 minus I to the power 4. So this you can write it as 1 minus I power 2 and then power 2. So you first start with 1 minus I power 2, which is 1 minus I, 1 minus I. So it will be 1 minus I plus I squared. Now 1 minus 2i, I squared is -1. So 1 minus 1 is 0, so we get -2i. So meaning, what we have now is 1 minus I power 4, sitting as 1 minus I power 2 power 2, and the inside is -2i squared. So meaning, we'll get 4i squared, which is -4, like that. You see that? So I'll give you 2 questions for exercise. The first one, 2 minus 3i power 3. The second one, 3 plus 2i squared multiplied by 2 minus 5i. So, meaning that you have a lot of work, and then tomorrow we're going to do conjugation, SADs, to prove that this is irrational or rational. And yeah, that will be enough. Meaning that we'll be done with tutorial sheet 1. So we'll be 80% ready for the quiz. Good night.
Good night, sir. Thank you.
Thank you. Good night.